Okay, so I was saying like uh, if I know my wire gauge, which I use for shortening the battery, if I know the capacity of the battery, the volts of the battery, the charges on the battery, then I can do this sort of experiment. But otherwise, it's not advisable. So मैं इसलिए कह रहा था कि मैं उसको दोबारा करना चाहूँगा क्योंकि मौका मिला क्योंकि अगर ये सारी कैलकुलेशन मेरे पास है तो then I feel I will be safe. लेकिन मुझे इन चीज़ों का पता नहीं है तो मैं डैमेज कॉज कर सकता हूँ, राइट? सो आई नीड टू बी वेरी कैलकुलेटेड इफ आई अटेम्प्ट दिस एक्सपेरिमेंट अगेन. So a huge current was flowing, and I had by that time I had a 400 DC ampere ohm meter. वो मैंने लगाया था, वो उसकी वैल्यू से निकल गई थी 400 एम्पेयर से. इट वाज ह्यूज करंट थ्रू द वायर. मैं कैलकुलेट नहीं कर पाई क्योंकि मेरे पास उस टाइम सिर्फ 400 एम्पेयर का ही पड़ा था. I was feeling like something is flowing in the wire. I was feeling those electrons, those billions electrons which were moving and were striking with other molecules. I was feeling that. But again, उनकी आवाज नहीं आ रही थी इतनी clearly. शायद मेरे कान थोड़े से कमजोर थे, but it was very late in the night. It was very calm. कोई noise नहीं था. But I was feeling that those electrons which are moving with tremendous speed in the wire. So feeling RAT, right? So what I mean to say, when this electron makes a collision, there will be heat energy. The electron will lose its kinetic energy, which it has gained from the electric field. It will lose that kinetic energy during collision. And that kinetic energy will transform into heat energy. There will be little noise, right? There will be little noise. So these kind of energies, and of course, there may be sparking, but you cannot see that because it's inside the copper, and copper is not transparent. So maybe there may be a little lightning inside, very is a little lightning. But of course, since it's very dense material, copper is very compact, so that lighting would definitely will not be visible. But the phenomena is there. Phenomena is there, right? Okay, so this is what happens. So we call this as the uh, we call this as the uh, drift velocity, the velocity of the electron just before the collision. We call it as the drift velocity. Okay, any question here?
No, sir.
No question. अच्छा, यहाँ पे कोई क्वेश्चन नहीं है. Okay, I guess it is 10 to the power minus 14 of a second. When the electron faces a collision. So the electron inside the copper takes around 10 to the power minus 14 seconds to make a collision. Or it's the time between two successive collisions. The time between two successive collisions. So this is also called as scattering time. Scattering time, it's for different materials, it will be different. Scattering time, you'll have different scattering times for different materials, but sometimes it is a little less than 10 to the power minus 14 seconds, and sometimes it is a little more. Again, depends on what? The cross section of wire. The scattering time really depends on cross section of wire. It really depends on the volts applied to wire. So it depends on the volts, and of course it depends on material. Copper, aluminium, gold, different material will have different scattering time, remember. This is for copper, okay? So, but remember again, as I said, it will be sometimes a little more than this value, sometimes a little less, depending on the temperature also, remember. Okay, depending on temperature also. And the length also. The length of the wire also plays an important role. So see, these collisions effectively making heat. Every collision will result in a heat. The electron will lose the kinetic energy which the electron has gained from the electric field, and that effectively makes the resistance of the wire. Okay, the internal resistance of the wire. Yeah. Any question here? No question? No question?
No, sir.
Okay. So, so when there's electric field, remember one more thing here. Just focus on this diagram again. Uh, what is mass of electron? Mass of electron is how much? 9.11 into 10 to the power minus 31 kg. Remember, this is the mass of the electron when the electron is freely suspended, when the electron is in the free space. Here inside the copper, the electron is not in the free space. Okay, there are many things around it, making lot of inertia for the electrons. Okay, so the mass of the electron will be m star, and m star will be little higher than the mass of the electron. But again, how much higher? That will depend on the material. In copper, the effective mass, the effective mass of electron, effective mass of electron will be little higher than the actual mass. In aluminum, it will be little differently higher than the actual mass, and so on. Okay, because look, if suppose see, this electron actually makes, this electron actually makes a kinetic energy. So in this kinetic energy, I'll not put the actual mass of the electron. In this kinetic energy, I will not put in this kinetic energy equation, I will not put the actual mass of the electron. I will not do that. I'll put the effective mass. Okay? Because look, if this is say water, and say this is air, and say I want to run through it, okay? I want to move through it. See, on my upper half of the body, I need less force. I need less energy for my upper half of the body to go through uh, uh, my head, hands, and many things. They will need less amount of energy, less amount of kinetic energy to move through the air. But this part of the body, surely it's through a denser medium, will require lot of energy, lot of kinetic energy. If I try to maintain the same speed, if I try to move vertically, if I try to move vertically through this two mediums, uh, one is air, the other one is water. Okay, so one is air, the other one is water. To have a constant speed of mine, or that I move in a straight line, I move vertically straight line, my part of the body will require less energy. The lower part of the body will require more energy to maintain the same velocity, because kinetic energy is equal to half mv square. Okay, समझ आ रही है ना बात की? So to maintain the same speed for the same kinetic energy, mass is different. You feel different mass. To maintain the same velocity, you need different kinetic energy. So your mass is actually different. Okay, though I have the same mass, but it see like in water, my effective mass is higher. In water, my effective mass is higher than my actual mass. आपको समझ आ रही है इस बात की? समझ आ रही है? बताए ना?
Yes, sir, आ रही है.
Yes, sir, आ रही है.
Okay.
Yes, sir.
ठीक है, तो हमारे पास जब कॉपर इलेक्ट्रॉन कॉपर में मूव करता है तो इसका इफेक्टिव मास थोड़ा सा डिफरेंट होता है, राइट? Okay, so one is the mass of electron, which is this is precise value. The other one is the effective mass, which is a little bit higher. The electron always moves, if the electric field is in this direction, the electron always moves against the electric field. Okay, so I guess for today this is enough. We'll continue with few more definitions in our next class. Okay,
Okay, sir. Inshallah.
so we'll continue
Yes,
with
sir,
more
inshallah.
details of the scattering and the drift velocity from here.
Inshallah, sir.
Yeah. So have a good time till then. Shortly I'll put
Sir, अपना ख्याल रखिएगा.
shortly I'll share these lectures on LMS and download from there. Okay. अच्छा attendance ले लेते हैं.
Okay,
Sir,
sir.
अपना बहुत ख्याल रखना, sir. Allah
Okay,
Hafiz.
sir. Okay.
अभी नहीं जाना, अभी सब्र